Well, welcome to the video. I wanted to put this disclaimer up front because I realized with the popularity of the Nano Goblin and the general growth in 3D printed airplanes, I might get a few more people coming by to watch this video than who normally just watch me fly around and crash into things. Just wanted to put out there that I'm not a professional YouTuber, and I have no intention of being one. There's no script, there's no audio guy, I don't have very high-end mics or cameras, but what I do have is a passion for the hobby. I really enjoy it. I like seeing other people be able to get invested in it and have fun with it. So that's kind of why I put these videos out. I like flying. I like video editing. I'm not really very good at either one of those, but thankfully in this day and age, you don't have to be good at something to put it on the internet for everybody to see. Anyway, what's going to follow here is a little short hype video talking about the Gremlin. Then we'll cover some of the history, what flying the Gremlin is like. Then there's a build portion, which walks you through the printing and building process. A video of that airplane that just got built going flying, talking about flying it. And then finally just a conclusion talking about why you might be interested in this airplane. Anyway, I hope you enjoy, and I think this is something that's really exciting. So, you want a Nano Goblin. Of course you do. Why wouldn't you? Gram for gram, it's one of the most fun airplanes available. With careful parts selection, it can be made sub 250 grams, if you live in a country where that matters. It's a stable airframe, efficient, and durable. I've taken mine in a lot of different places, and flown in a lot of different conditions. There's just one big problem. You can't get one. Ready-Made RC hasn't discontinued them, however, they've been out of stock for a long time. The INAV Fixed Wing Group did an interview with Tom Stanfield of Ready-Made RC a few months ago. My take from that was that it wasn't likely to be something that changes anytime soon. He cited the supply chain, shipping, and production costs being so variable and often unreasonable that it's not financially viable for them. It sounds like they do plan to bring it back once they can, but the world doesn't look like it's settling down anytime soon. There are some planes that are close. I've been very happy with my Zod Dart 250 and seen some great video out of the He-Wing T1 Ranger. But there is a reason the Nano Goblin is so universally loved. And not being able to get a replacement must weigh on others just like it does me. My Nano Goblin used to be the risk-taker airplane. However, the reason you don't see it much in my videos is it's become the precious plane in the fleet. I tend to use it more for relaxing flights where I'm just taking it easy, rather than the days when I want a challenge and see how many spots a foam airplane will fit through. So in comes Justin, or JWM Flying 14 on RC Groups. He's quite a background in aerodynamics and has been involved in the development of composite fixed-wing drones for industrial use. Needless to say, if you wanted to have someone develop a derivative of the Nano Goblin, this would be the guy. And thus, the Gremlin was born. While it looks like a Nano Goblin, Justin actually created a custom airfoil, or rather two, blended between the root and tip of the wing. The result is something that should have a little lower drag and be more efficient than the OG Nano Goblin. Though I'll put a giant caveat on that, and I'm sure Justin would agree, that 3D printing, even with lightweight PLA, is going to keep the plane on the heavier side, which will hurt overall efficiency. On top of that, the 3D printing process introduces a rougher skin that also induces more drag. At the time I made this video, no one had done any real efficiency comparisons. I don't even have a current sensor on the FC I'm using to see the amp drop. Justin released the plans to the beta testers, I flew the first one line of sight just to get a feel for it. Justin was making continual improvements, and my next version was a full setup with FPV and INAV. This plane was a blast to fly, and it used a combination of lightweight PLA and PLA+. Lightweight PLA for the wings, and PLA Plus for the body and nose. Once you get this in the air, you'll feel very much like you're flying a Nano Goblin. While flying it was great, launching was a little challenging, so Justin slightly extended the wingtips to give us a little bit more surface area and tweaked the vertical stabs to improve yaw stability. After that one, I printed the next design that Justin came up with, which is matches the aerodynamics of the version that's been released, though Justin did continue to make numerous improvements like the hatch design and how the tail fins connected. He also introduced me to something called pre-foamed lightweight PLA, or passively foamed lightweight PLA. And I'll talk more about this during the build part, but I think this is a must-have if you want to get the best performance out of the Gremlin. Let's focus on the flying first. One of the best comparisons I have is a friend's Nano Goblin chasing my Gremlin. You can see here the Gremlin DVR versus the Nano Goblin DVR. But both planes are doing well for a sunny, bumpy afternoon. The Gremlin seems to be more stable, particularly in the yaw axis. I don't want to declare that the Gremlin is the better flyer just from a single data point, though. This red Gremlin was made from PETG, not lightweight PLA, and is considerably heavier. The higher wing loading tends to lead itself towards better turbulent air penetration, as well things like the flight controller tuning are also going to have an effect. I was flying mine in manual, but my friend was in acro mode. Additionally, that particular Nano Goblin has been crashed a lot. It's not quite as firm as one out of the box. Regardless, though, it should be obvious that the Nano Goblin can hold its own. Mention this now, Justin designed this plane around the same 2S 18650 packs that most of us use on the Nano Goblin, but I so far have not had any luck running the plane on 2S. With lightweight PLA, the slightly increased area that the Gremlin has, it's pretty close to the Nano Gremlin in terms of wing loading. However, it's still heavier, and I think that weight increase means the plane tends to struggle with acceleration. I was never able to successfully launch it on 2S, though it came pretty close and I'm sure it would work in the right circumstances. If you have a bit of wind, maybe a little lower elevation, prop change, several things that you could try. However, I need and want reliable launches, and so I bumped up to an 18653S and was very happy with the performance. My build isn't optimized that well for weight though, so if you're built fairly light, don't let me put you off trying the 2S 18650. It just might work well for you. When you want to build a Nano Gremlin, the first part you're going to want to look at is, of course, 3D printing the parts. Now, here's the most important step which is selecting the filament you're going to use. Now, if you've 3D printed airplanes before, chances are you've used PLA. That's one of the more common filaments. And if you've done some 3D printing lately, you've probably at least seen or heard of the lightweight PLA or foaming PLA. That's been a game changer in the 3D printed airplane world, for the simple fact is that you can generate 3D printed parts which are almost half the weight of a traditional PLA part. However, that does come at some costs. It can be a little bit challenging to 3D print lightweight PLA. The design usually has to be set up around that the lightweight PLA, as it usually is a little bit more flexible, maybe a little bit more fragile, so you do need a little bit more structure in place. But the end result is you get an airplane that's quite a bit lighter. Justin, the designer of the Nano Gremlin, actually showed me or told me about something I hadn't heard of before, which was pre-foamed lightweight PLA. I'm not sure who all makes this. Polymaker is the one that I'm using, so that's a Polylite pre-foamed PLA. This has several advantages. One, it prints much easier than lightweight PLA. You print it with normal settings that you would use on a standard PLA. Maybe some slight adjustments to retraction. And like any filament, I recommend you put a little bit of time into trying to tune it to get the best possible result. But you get almost the same weight savings. It's 0.8 grams per cubic centimeter. Versus, I believe, foaming PLA, you can usually be down to as low as 0.65. So very close to lightweight PLA in density, much lighter, of course, than your normal PLA. And that's the material I would recommend. It's the one I've been building most of my designs with, though I have experimented with PETG, PLA+, etc. I'd also recommend it for the longevity of the airplane that you printed in the white lightweight PLA or poly-light PLA. And that's just simply because if you don't have any experience with 3D printed airplanes, the PLA reaches its glass transition temperature inside of a hot vehicle, or if the airplane is exposed to sun with no airflow, and all of a sudden it'll start to soften and it can lose some of its form and structure. Usually you'll see the dimples and stuff like that on the wings in between wherever the internal structure is not giving it any support. So white is probably your best bet. It's the most likely to survive sun exposure and hopefully give you a relatively long-term aircraft. So I know Justin is working on a manual for this, which is likely going to include some detailed printing instructions. Where I just wanted to go over it a little bit just to give you guys a little bit of a guide before that gets started. So down here near the bottom, he's going to talk about the 3D printing settings. Now, if you've printed other 3D aircraft before, you may remember that you often need to use very specific slicer settings, often multiple types of slicer settings for the model, depending on what you're printing out. And Justin's designed this to print kind of with one set of settings so that you can load up the build plate, add items to it as either as much as you want or do it one part at a time and have it print out nicely. So you're looking for somewhere in that 0 to 10% infill. What I usually do is in Cura, I'm usually printing in the lines method, and that's just because it gives you the most cross-section area in terms of it's going to put the most amount of lines down with the least amount of plastic, so it alternates the lines in the direction. 0.4 millimeter walls, a 0, so that's a single perimeter, a 0.8 millimeter top and bottom, so if you're typically using a 0.2 millimeter layer, that's 4 millimeters top, 4 layers top, 4 layers bottom, and of course you should be printing with a 0.4 millimeter nozzle. Strongly recommend you use a brim, and that's just to make sure that your parts don't warp or come off the build plate. And you should require no supports on any of the prints. As far as many of the other settings, it's going to depend on what filament you're using. The lightweight PLA from Polymaker, which remember is the passively foamed PLA. That's actually the material that Justin recommends, and I've had a lot of luck with as well. So that's the Polymaker's passively foamed lightweight PLA. You get roughly 30 to 40% weight savings over standard PLA. It's not quite as light as the normal active foaming lightweight PLA, which can be as low as around half of the weight of a standard PLA, but it's so much easier to print, and the quality you get out of it is much higher, in my opinion. So I think it's worthwhile. I think it's worthwhile for this print. The nice thing it also lets you do is anybody who's printed with lightweight PLA knows you basically have to print one part at a time. However, with the Polylight's passively foamed lightweight PLA, you can print a full build plate, and because the stringing isn't any or much worse than normal PLA, and so you can do a full build plate if you want. Though if you are looking for the best quality, you probably still are going to want to print one part at a time, or at least only a few parts at a time, and maybe make use of some other tools to help out with that. I found the same thing as well. Cura version 5 was creating some unusual artifacts, so you may want to roll back to the latest Cura 4 version and use that as your primary printing tool. I printed with both Cura, and I also use Simplified 3D. As somewhat usual, I find Simplified 3D ends up giving me the best results, but of course it's a fairly expensive program that hasn't had any real growth or change in the last probably 3 years. So it's hard for me to recommend it for anybody, even if I do end up kind of getting a little bit better results on it. Cura is perfectly capable of producing the results that you need. Alright, so let's talk about the parts that you need to print. First thing you're going to probably want to print is the main fuselage body. That's this Gremlin center body piece right here. This is printed nose down, so this is the edge that contacts the build plate. This is one of the largest pieces and will probably take one of the longest time to print. but it's good to get it out of the way because it gives you the starting point. From here, you can start adding your servos already, potentially your flight controller, even your motor mounts and stuff like that. Almost everything fits inside of this body with the exception of the camera setup and battery. So you can actually have one of these almost sitting ready to go and then print off and add the parts as you finish them. From there, you may want to select the forward portions. So this is the section that's going to go onto that body, and this is the section of the nose that sticks out. And here's part of the caddis antenna holder. From there, you're going to select what nose cone is going to be appropriate for you. There's a nose cone built for the Nebula Pro, or cameras that fit that size, and the Nebula Nano, as well as a blank nose if you want to try and cut your own. The Nebula Pro mount is what I'm going to be using because that's the camera that I've got for this, or the same size of camera that I've got for this. And this piece is printed nose up. So this will be the bottom surface down here. You'll have the 3 pieces for the tail. So this is your vertical stabilizer. And these 3 pieces glue into the slots you'll see on the main body piece. Now, Justin's built all these parts with just the left-handed side, so you just need to mirror them in your slicer, which is fairly simple to do in all slicers that I've made use of before. And it's probably fairly self-explanatory which end goes down. It's this open end goes down on this one. Technically the middle wouldn't matter, but I usually just put the longer side down, and then the tail should be set up to go again with this side facing down. Then what you're going to have to decide on is whether you're going to print the wing with or without the leading edge. So Justin's designed it so that you can actually create a different leading edge with a different material. And what this would allow you to do is you could print the wing out of PLA or lightweight PLA, and then print a TPU leading edge, which would potentially give you the ability to survive a little bit more impact. I think it's a great idea. I personally haven't really gone for it, though. I don't think... I think in a lot of cases the impact is going to be more severe than what the leading edge is just going to handle, and particularly the nose is going to break off. So I've just kind of chosen simplicity, which is the normal wing with the leading edge already built in, so it's going to make it out of the same material. But there's nice that there's the option there, and here you can see the opening for the 6mm carbon spar. And again, these parts are only going to come in the left side, so you do need to make a copy and mirror them in your slicer. So here's your elevon with hole for the 3mm carbon tube, and then the leading edge on the root side. And when we do the actual build, we'll show how this, we need to make sure we put this in the right side. The smaller side is actually the side that goes against the fuselage. So if you're looking at the center body here, you may want to hold off gluing those pieces on, but if you do look carefully here, you can actually see that it makes sense. The wider or taller side is towards the outside, where it gets thinner towards the inside. And I glued them on the wrong way the first time because I glued them on first. Now what I do is I glue on the wings first and have everything set up, and those are actually one of the last pieces I put on. So I put the nose on first, the wings on, and then I glue in that leading edge root piece there. And then it's very obvious if you've put it in the wrong way. Wingtip, obviously open side down. Again, print 2 copies of those. Then your Vista mount is going to be, this is a glue-in mount, so you glue this into the nose piece based on the camera you have. So your Vista screws in here. These 4 holes should line up with the 20mm Vista holes, and then the camera is screwed into here, and the whole piece slides in and is glued into place. Now the Vista can be recovered by unscrewing these holes, but the camera will be glued into place and really not accessible. So you really want to make sure that you double check that the camera and the Vista are connected properly. I know I've had cases where I put it into a plane, realized the cable had come unseated in the last crash or something like that, and needed to be reset. So you want to make sure you do that first before you glue it permanently into place, because it's going to be very hard to get to otherwise. If you've got the Nano camera, then you're going to use the 14mm design, obviously the larger camera for the 19mm design. Now the motor mount, there's two motor mounts. One is the external mount and one is the internal mount. You can see how they're kind of flipped around. So they glue into the aircraft the same way. You can see how we're kind of just switching where the outside of the mount is. Now, Justin originally designed the internal mount, so your motor goes in here, and this actually kind of comes almost to the tail end of the airplane, and it just sticks out. And I had a really hard time with this because some of the motors I have, if you can't grip that bell very well, even using a tool, very hard to change the prop. So I actually requested Justin build the mount so that the motor's stuck outside the plane. No issue with cooling or anything like that. You could definitely have the motor on the inside like this. But if you're in the field trying to change a prop or something else, I mean, it's just, if you can't grip the motor, it's really hard to do anything with that. You know, you're needing to use some sort of a tool to try and jam or hold that motor in place. And then some props just, they don't want to let go as easily. You know, some of them will slide on and off relatively easily, but some of them are so tight that with that inside motor like this, I just didn't feel like I would be able to get the prop on and off relatively easily. So I made use of the external mount, which does shift the CG back a little bit, but so far I've had no issues with balancing. Lastly, we've got the canopy. So it's split into a fore and aft piece, fairly self-explanatory. Obviously, this is going to be the top side of the fore piece, and the aft piece, again, the flat side, is going to be the side that you put down on your printer. And this latch right here, you're going to print so that this side, it goes on its side, so when it prints that it should be fairly strong, no supports or anything weird like that. And then we'll glue it into this opening over here, and that forms our latch piece. There's a couple of alignment tabs here, so to be honest with you, I haven't printed this out yet, so I'm not even sure exactly how many you're supposed to need here yet. My print build, the print that you'll see here in the build video was done before this release was ready, and so mine doesn't have these alignment tabs, so I'm sure it'll probably be fairly self-explanatory. I may do an updated build video once I've had a chance to print these all out. When printing, I'd suggest you make a custom material, the Polylite lightweight PLA. And if you never managed materials in Cura, you can just do it in part of this section here under Manage Materials. And you can build your own custom materials. And the reason why you should make this custom material is because you should probably have the density set in here correctly. Polylite lightweight PLA, that's what you're going to be using, which again I highly recommend, is 0.8 grams per cubic centimeter. And you'll notice that's decent percentage or decent amount less than normal PLA. And when the slicer actually slices this part up, let's make sure I got the right settings on here. Yeah, we've got our single wall count. Yeah, looks good. When the slicer slices this up, it's going to tell you what the weight's going to be. And so far I found Cura's estimate to be very reliable. And again, I believe as part of Justin's manual, he's likely going to have the listed weights for each part. If not, then I may try to do a measurement on mine next round when I print out these production parts here. And that having that weight is important because we're going to compare that to our actual weight after we've done printing the part, and we're going to want to, before we even print the part, compare it against, for example, what Justin says the weight should be, because that needs to be within reason of what he's saying the actual weight will be. And if you look here, I'm showing at about 45 grams for this part, which has been in line with all of the prints that I have kind of done with this piece, at least in the lightweight PLA. In normal PLA, I was ending up somewhere around the 65-ish grams, so you can see there's still quite a substantial savings by going with the pre-foamed or passively foamed Polylite lightweight PLA. And of course, just like any other 3D print, you want to give it a good look through before you actually hit the go button. Make sure that the parts look good. You can see that nice thick brim there to make sure it stays in place. No supports or anything else particularly bad there. I've got the travel modes turned on. I've been fighting with Cura to try to get it to reduce the travel mode. That's what the combing feature is supposed to do, but it doesn't seem to handle it very well on these kind of prints you're seeing. I still get a lot of travel movements that I was hoping to be in the skin. This is where Simplified 3D was definitely doing better for me than Cura. But this should still be fine. And again, one of the spots to check here is down here at the servo hole. Make sure that you're getting the material to bridge nicely there. And I'll just double check if mine is. And it's not. So it's just doing a normal print right there. So if I go to bridge, and I set up a minimum bridge. Anyway, I reduced this minimum bridge wall length to 4 millimeters, and I believe this is now giving me the result that I want. Again, on Simplified 3D, I had to tweak this setting, and it seemed a little bit more clear. But it seemed a little bit more clear there. But I believe I've done what I want. I just want it bridging across here nicely and without any sagging in there, because that can make it, depending on the size of your servo, a little bit of a trick. You got to clean that edge up as it bridges there if it droops down a little bit. Otherwise, you just go through the pieces one by one, or you can print them all at once. I have checked this will fit on an Ender 3 with the entire build plate. Is able to fit all of the parts that you need to make this airplane. So that is an option. And again, with the Polylite lightweight PLA, you can do that because there's not a crazy excess amount of stringing. But again, best quality is going to be if you print only one part at a time rather than all of the parts at once. So it just depends what you're aiming for there. The only parts I don't recommend printing out of the lightweight PLA is the motor mount and potentially the caddx mount. Both those on mine I'm going to end up doing out of PETG, just because of the better temperature resistance. And then one thing to be watchful of with the motor mount, one thing I'll point out here, because sometimes it's easier to see than when it's printed, is the motor mount does have an arrow on it. That defines the up direction. So do be cautious, or do be aware of that when you're installing your motor, that it does need to be installed with the arrow pointed up towards the aircraft's top. Now that our 3D printer is going, let's talk about the hardware we're going to need. You're going to need one 6mm diameter carbon tube cut to approximately 400 millimeters of length. You're going to need two 3mm carbon rod or tubes cut to exactly 205 millimeters of length. Two servos of approximately reasonable size, some around 5 to 9 grams. Two push rods with appropriate attachment hardware. You'll need an ESC of approximately 20 amps or so, relatively light. If you're using a flight controller that gives you a 5-volt regulator, then you might want to focus on something like a multicopter style ESC that's very light and small, BL Heli or BL Heli 32. Motor selection is up to you. There's some various options out there. I believe the 1507 Brother Hobby 4300 kV, I believe, is the recommendation from Justin. I've tried that motor. I've also used one of these Zing 1408 motors, some sort of motor in that sort of size range, coming in anywhere around the 4000 kV mark should be appropriate in most circumstances. We'll talk a little bit more about the motor selection when we talk about the finished aircraft here. Yeah, of course, if you're going to use a flight controller, you'll need to have that as well as a GPS. As far as tools go, you're going to want a nice sharp utility knife, probably a pair of angle cutters. You'll also need your CA glue. I recommend a gap-filling medium CA glue, and I recommend having a kicker or accelerator as well, just to make the build process a little bit simpler. As the parts come off the printer, you're going to want to work on cleaning them up. Now, if you printed with the settings as per recommendation, you're going to have a brim around the parts, and so you're going to have to peel that brim away depending on how relatively tuned your printer is. That brim may come apart really cleanly, but if not, you can use your utility knife to kind of finish off that edge and make sure that it doesn't have any rough parts or rough edges to it. Likewise, if you've had a little bit of issue with retraction, which this pre-foamed lightweight PLA, I've struggled to get really good retraction on it. So if you do have some lines, the nice thing is it cleans up really nicely with, again, a nice sharp utility knife. And if you look at that, compared to a non-cleaned up element, I don't know how well that shows up in the video, but you can scrape off that that stringing really easily with this type of filament and make it look pretty clean. So I usually just take my knife and very carefully, because you don't want to slice yourself, go across there and clean up any residual filament that isn't in the right spot, and then of course finish off cleaning up the brim. So you want to have those parts nice and reasonably smooth. This filament will sand quite nicely, so that's something you can do as well. And again, if you really want to optimize how it looks, rather than printing it as a large single file print where you print everything at once, if you print each element by itself, you're not going to have much of that same stringing, especially on the smaller elements, other than maybe the body. For my build, I'm actually going to be using a different set of electronics than what you see pictured here. I'm going to be taking the electronics out of this PETG version. This is one of my testing models you might have seen in the previous video. It had a relatively minor crash, and you can see the kind of damage that you'll typically expect with a 3D printed airplane here. This airplane is repairable. It wouldn't be that hard to glue it back together. Really, it's just the nose that broke off, and it broke off relatively cleanly. There's a few other cracks and stuff like that, but those could easily be filled in with CA and strengthened back up again. So the only reason I'm doing that is because this aircraft was printed out of PETG, which of course looks really cool, this transparent PETG, but it's quite a bit heavier than the lightweight PLA. So we're going to be stealing actually most of the electronics off of this one, and that'll go into this new white version that we're building right now. Though since this aircraft is repairable, I think I might actually try and save it if I can, so I'll try not to damage it during the removal process. I have my 3D printed parts ready to go, and I've got them mostly cleaned up. Just got a few remaining items to go. The hole for the control rod on the elevon, it's just kind of got squished flat on mine, so I'm going to use a drill to clean it up and just make it easier for that rod to fit in there. Next, I'll take my carbon rod and make sure it's going to fit, that there's nothing in the way. There, you may have some stringing here, and thankfully, as long as the stringing isn't too bad, with the lightweight PLA, it should just give way without too much trouble and allow you to assemble it approximately in the center of the design. And we can just do a test fit of our wings here. This stringing is really bad. You may want to push the rod through there a bit to kind of clean it up. This wing isn't too bad. The outside surface didn't turn out great. I was playing around with a few different things, and I tried printing this as the full design. Again, you might see some variation here. This isn't actually the final production version that Justin released, just one of the pre-production versions that I had printed out already previously. But all of this should fit relatively the same. There shouldn't be any major changes from that version alone. Anyway, now that we've got that elevon, or that wing temporarily on there, I'm just going to take a look at my elevons here and make sure that they're going to work nicely. So I've got that pushed in so that we're a little bit sticking out on either end. And this is just key because when it comes to assembly on this thing, with most 3D printed airplanes, you really only get one shot. That's the other side. And I just want to have this test fit here to make sure that it does in fact fit. And that when it's fit together, the control surfaces will move smoothly. And they appear to be a little bit stiff. I unfortunately never got my hands on a 3mm rod. Ironically, that was a little bit tricky to come by here. And so I may have to just widen this slightly to make sure that the elevon will move smoothly. You shouldn't have to do this step if you've got a 3mm rod. Mine are 0.125 inches, which is actually 3.18 millimeters, so it's just a little bit too big, which is making it so it doesn't want to fit in there nicely, but I think we've got it now. You want that connection to be relatively smooth. We're definitely not going to put any glue on the mating surfaces between here and here. You could put glue into the elevon itself to help hold the carbon rod in place, but I don't think you need that, and it'll make it harder to remove this part later if you crash and want to transfer parts to a different airplane. So I'd recommend just not bothering with glue on that junction at all. We'll see where the glue is going to go here in a second when we get to the actual assembly, and that's plenty strong enough from what I've been able to tell. Anyway, that looks good there now, and now the elevon looks like it fits correctly, and I'm not creating any pressure on anything by holding this here, so I'm happy with that. Next thing you're going to want to do is to take your servo and feed it through. So the servo horn goes up, or the servo arm, and it should be towards the forward portion of the airplane. So feed it through the slot on the side, and you can pull it through. Now, if you're using a something smaller than a 9-gram servo, you'll likely just be able to slide it into this slot without too much difficulty. However, some 9-gram servos may be pushing the edges of what the dimension it can fit, just like mine are here right now. These aren't probably what I would consider the ideal servos, but because of a crash I had which damaged the smaller set I had, this is the ones I've got available. In that case, you can just take your knife and carefully shave away some of the plastic around the bottom edge. I can break that. The other thing to watch out for is the top edge of the servo hole. If you get any drooping here, that may be the other thing that's preventing you from getting the servo to fit. So that's another spot you might want to remove just a bit of material, not too much, but enough that the servo will fit in there without too much trouble. And there we go. The servo is now in. Now you'll want to secure this servo down with some method. You could use servo screws just screwing into the PLA. You could use a little bit of glue. Mine is actually friction tight that I could probably just leave this, but just because I don't want to have it loose in any way, shape, or form, especially if the PLA softened ever so slightly, I'm just going to take mine and just add just a small dab of hot glue, and just to help secure it into place. Now, do be careful with hot glue and PLA printed parts. Obviously, PLA and heat don't tend to mix, so you never want to use a large amount of glue. That heat transfer will soften the PLA and could possibly lead to it deforming, and maybe deforming to the point where it doesn't work very well. May change the overall shape of the design. So just a bit of hot glue, or you could use a glue that doesn't use heat, something like Foam Tack or E6000 or something like that. But I do want to leave my servos always removable, so I don't want to make use of a glue that will create a very, very strong permanent bond like CA. That's just my opinion. I choose not to do that. Now, these servos here fit very nicely going into here. And what I should have shown you here first was the test fitment that I did. I already did this, so that's why I skipped this. But before you glue that servo in permanently, you're going to want to do a test fitment here and make sure that it's going to work with the cutout that's meant for the servo arm. I did have one servo design that was taller above where the tabs are here, and it didn't want to work with this servo opening, the horn opening here. And so what I had to do in that case is, instead of sliding the servo in from the outside, I actually pushed the servo through from the inside and had the tabs on the inside portion, or on the inside of the wall here, and that left the servo arm in the right place. So that's why the fitment is important here. Want to make sure that it's going to work nicely. I already knew these servos were going to work because they were in a previous airplane, or a previous Nano Gremlin here. So, but you do want to make sure you do that test fitment before you glue them in. So let's put the other side in. At this point, if you did do your tail surfaces separately, which I don't believe there are going to be public files available for these combined surfaces like this, but you would probably want to glue those on now, get that out of the way, and you just glue on the three pieces. It should be fairly obviously, there should be a left and a right side. Actually, there's only a left side which you have to mirror, but of course you'll have the mirrored side printed, and you just glue those on with your CA glue, just like we're about to do with all the rest of the parts. Again, if you have any cleanup to do on a part, you can kind of do it as you see it, as you notice it. Obviously, when you're working on a nice sharp knife, and you want to be careful when you're using it, and you don't want to cut yourself while working on this. And just wanted to mostly cosmetic, but you also do want to make sure that there are no bumps that are going to be poking out and interfering with how clean the bond is between the body, the nose segments, and the wing root segments. So you just want to make sure that there's going to be no, partially that's for aesthetics, but you also, help minimize drag if you don't have anything sticking out from there. Doesn't have to be perfect, but the nicer you can get it, the nicer the plane will tend to look. So from here, I'm going to choose to assemble the rest of the wing surface. There's no set order how you do this. You may want to, for example, build up the nose first, or get all your electronics in place, everything done up until this point. In fact, what you can do with this airplane is get it set up with but the way I like to set up this airplane is I want to have a couple of these airframes actually ready to go, and that's because we'll see here in the final electronic stage, if you've got your electronics set up right, it's a very quick changeover between aircraft. So if you ever have a crash, you could actually probably do the replacement at the field with only a very small subset of tools available to you. So I'm going to continue on with building off of the body first, and then we'll do the electronics kind of as the last stage that you might want to do. By the way, I am again choosing not to glue in the spar. The spar is held on fairly well with just via friction alongside the internal spar structure. And the reason I don't want to glue it in, or if you are going to glue it in, make sure it's not with CA glue, is that again, after a crash, this can all be removed and moved on to the next airplane, which is in fact where all of the parts are coming for this airplane. The carbon spars and the servos and stuff like that, and all the rest of the electronics we're going to put in here actually came off another airplane. So that way, if you minimize glue where you don't need it, the aircraft is very quick to change over. Alright, so the camera didn't record that last wing going on, but we'll show this wing, which is the more or less the same thing. I'm pretty sure you guys can figure out the left and the right there. Just repeat it the same way. So again, we're going to make sure that the surface is clean. There's nothing left to clean up yet on the brim, so very carefully using a nice sharp knife, we'll just make sure that there's nothing sticking out. Want to make sure that the surface is really in good shape here. No bumps that are gonna mean that only the CA is holding things together, even though the CA is probably considerably stronger than the filament itself is. It also just doesn't look as nice if there's big gaps that are being filled in with CA rather than just our initial plastic or actual plastic design. This is probably your last best chance also to clean up any roughness on the outside surface. Get it as reasonably good and clean as you can. Again, I think I mentioned that I printed this with I was playing around with settings a bit, so it's not maybe as nice as some of the other builds that I've made so far. I did the whole print all at one shot, one plate design, and a little more stringing and stuff like that than I was hoping for. But anyway, once we got it set up, I'm going to put the CA on, and I'm going to avoid a couple areas. I'm going to avoid where the spar goes into, because I don't want the spar to get glued into place. And I'm going to avoid the leading edge here because you'll see in the files there's two designs here. One that there's no leading edge here, and you print it separately, or in this case there is this leading edge here, and I am going to have a separate root leading edge that goes along the front of the airplane over here. So we're going to leave this spot, no CA here, no CA here, and no CA right close to the servo itself. Don't need to put on too much. Well, if you put on too much, it just tends to run down the side, which, oops, I got a little bit going right there. Because you missed it on the other side, what I did was I held the spar roughly in the right spot so that it wouldn't slide, and I'm sort of going to do the same thing here, holding in the middle, but just from friction from the other side. I shouldn't really have to do this quite as much. And we'll just slide it on, and there's a little bit of CA there that spot I don't want, so I'm just going to try and clean up some of that. And before it gets touching here, and anyway, once we get it going there we go, we'll have the connection made. Now CA, we're in no rush. It's got plenty of working time until we hit our kicker on there. So you want to take your time and make sure that it's as aligned as possible. I do believe, I'm a little uncertain on the final design. I know Justin is working on some ways to make this join easier. Little tabs or something like that. But if you don't have those tabs, then you want to just make sure this is lined up as possible. Hold it in place, and then just hit it with the kicker. Give that a few seconds to set, and then bring it around. And again, get it in place. Hit it with the kicker, and give that a few seconds to set. At the end of the aircraft design, or the aircraft build, sorry, I will typically go through and try and spot any big gaps like that. And I mean, the CA we're using is called gap filler, so I just use it how it says, and I just fill in those gaps, make sure we got a nice strong connection there. But of course the goal is to make sure that we have as good of a leading edge as possible. So you should have already done a test fit on this, so there should be no surprises here when you slide this into place. And just want to make sure that there's a little bit of room on either side. Let's really do a retest fit here, just to make sure. Make sure there's a little bit of room on either side, so that when it is sitting in there, it does have room to move, and it looks like that's okay. And again, don't forget that this elevon needs to be in here. And if you haven't already, make sure you've drilled out the hole for the clevis or Z-rod or Z-bend rod or whatever you're going to have for connecting your push rods here. And it should sit close to flush here, but just on a little bit on the inside, because remember, this surface needs to have a little bit of room to move. And again, when we put on our leading edge, or sorry, correction, our wingtip, we're going to use CA on most of it, but we're going to avoid anything past the back section here. So if you want to know what you should be doing CA, I usually put CA on the wing side instead, because it makes it fairly obvious that I don't want any CA anywhere near this elevon surface, because if this CAs to your winglet or onto the wing itself, well, it's just not going to work, and you may have a hard time breaking it free. So I'll give us a little bit of room there so we don't get too close, and I'm not going to get the CA too close to that. But over the rest of it, we can, again, we don't have to put on too much, just enough to make sure that it's going to stay attached. I put on the winglet to the elevon first, because sometimes you got to get a little bit of a wiggle. Again, if the test fitment, if that didn't fit in there very nicely, you would want to use a knife or a screwdriver or something like that to help open that up a bit and make sure that it wasn't going to be a problem for you. Now, I'm going to try and do this on camera as much as possible, but it's a little awkward, and I don't want to end up with it not fitting correctly, so I'm going to, I may have to go off screen sometimes for when I'm holding it here. Actually looks like this will work, so we give it a little shot. A little bit. There we go. A little bit CA to the plane. That does happen a bit, I think. Get a little bit of CA on your fingers, trying to get these fitments just right. Again, on the production model, I think you're going to have some tabs here that will assist with this. And let's just make sure our elevon moves freely, and it does. And you may just want to watch that connection a little bit, make sure that no CA got in there, and make sure that looks good there. And it appears to be okay. When installing the latch, you'll want to test fit it first. Depending on if you've got a little bit of stringing or a little bit of deformation from the 3D printing process, just the heat at the top, you may need to take a pair of angle cutters and just kind of snip away the very top end of that aft hatch piece. And you'll see why when you do the test fit, why that's important. If you can't squeeze the latch between to the open position, because there's some plastic in the way, you just need to make sure that you cut that away. I found I tend to use a little bit of E6000 on this part, and then just followed by CA to kind of finish it off. And it's just because for some whatever reason the CA glue, even though it normally gives such a really strong bond, I don't know if it's just I haven't been patient to let it cure properly, but it has seemed to be a little bit on the weak side. So I just beef this part up with a little bit of E6000 to make sure that that latch stays in place. You'll want to remove a prop if you have one installed. That's because the motor mount and motor need to be pushed through the body as part of the installation process. So install the motor using the provided screws. Obviously make sure that they're not contacting the windings of the motor when you're pushing the screws through. And once you have that mounted, make sure you make note of the up arrow on the motor mount. And you'll see here why I generally recommend doing this one of the earlier steps, because doing it now with the spar and flight controller in place makes it just a little bit that much more awkward. So you'll push it into the body, slide it down to the back, and just make sure you got a good test fit in there that it looks like it's going to mount straight. And then you'll apply a little bit of CA glue to each of the 4 arms that are contacting the aircraft body. And again, insert it, slide it down there, and make sure that you end up with a straight motor mount. What I've been doing is when I get to that stage, I slide it down there, and I actually just lightly test fit the prop back on. That just helps me make sure that that the motor mount is going to be straight. All right. So overall looking good. I am getting a lot of vibration on the FPV camera. Now, that could be a lot of different things. I had this on the initial FPV model, and I thought that just my design here on the Cadix was what fixed it on my next version, or on Justin's next version, but it appears to be back, and I wasn't having this on my black lightweight PLA version, so it makes me wonder, it does make me wonder where it's coming from. Could be the motor mount. Flies good otherwise. Yeah, really, yeah, it's just that gel is a bit annoying, so I'm gonna have to do a little investigating on that. I'm not using Justin's design. He didn't have it out yet at the time I made this airplane, so I will probably be reprinting this airplane soon again, and hopefully that design doesn't have this jello issue. But otherwise, you can see it's flying great. It's you know, it should be fairly obvious just from maybe looking at the clouds and stuff, but it's a bit of a blustery day. And helper showing up. For some reason I'm getting better. I'm getting a better flight out of manual mode than acro mode on this thing right now. And it has to do with the fact that angle mode keeps pitching down. And I have auto trim enabled. I'm not quite sure what that's about. Again, I don't think it's an airplane issue because as you can see, well, probably can't see, but right now in manual mode, I'm not experiencing the same problem. So, probably a flight controller related issue. Because I was doing this before on the black and red PLA designs. Basically been doing it consistently since I've been using this flight controller, which makes me think I should double check my settings and verify that auto trim is on and actually turning on, and see if there's any specific conditions related to that. Because it does hurt my acro mode. I'll go back, try acro mode, see now acro mode's behaving. Maybe it was just a I'm just very happy with how this flies. Obviously, you'll be seeing the jello from the DVR, which is unusual. Like I said, we saw this, or I saw this on my first FPV model, and then I thought just a combination of Justin's changes, and I kind of upgraded this what I made for the Caddx Vista to fit in here, not what it said, not what Justin has for the release, and that jello went away. So I'll have to do a bit of experimentation with it. Though this airplane is not likely long-lived, now that I've got the release files, I'll be planning to reprint this again and see just how much easier just to be able to put it together. Because now Justin's added tabs and other things to make the alignment a lot easier, as well as his own. He's designed a Caddx mount. Okay, so here we are at nice high altitude here. So we're going to do a power off stall. So I'll bring the throttle to 0, and I'll just let the let's see what the flight controller does with it. Nothing really. It's letting the nose drop a bit, just typical iNav, right, with its pretty weak I-term correction. Then with 0 throttle, yet it makes it worse. So let's go to manual mode. Try the same thing. And now let's force the nose to stay up and see what we get. And that's full back. And there is that typical, I've heard people call a hyperstall behavior. Drop it about 3, yeah, maybe less than 3. Oh, actually that's stabilized out there, but 2 meters per second descent rate. So really very gentle descent rate. And I still have control over the airplane. I can still steer it. I can put control inputs in, and the wing doesn't stall or enter a spin, or further stall, I should say, and enter a spin. Quite reasonable stall characteristics. So you can feel pretty comfortable flying this airplane slow and low, which is something I like to do, knowing that it's almost like there's a, you know, definitely there. It seems worse at a particular RPM. That's very interesting. That it could be a shutter speed, but no, I think the shutter speed. Yeah, it could be partially a shutter speed issue. Why it's worse now than it was. There is interestingly, certain power settings, like right around here, where it's really bad. So that means it's certainly tied to the prop and the motor. And I'm not sure what I'll need to do to investigate that. I could remove, I'm using my own motor mount as well right now. I could remove it and try Justin's external mount and see if that helps. Here's just showing another stall. You can see we're full back, and we can still steer. So I'll steer us back to the right. Obviously, when you steer, you rapidly increase the descent rate, but then it quickly ventures back into that hyperstall. And I mean, it's a survivable. Maybe a 3D printed airplane wouldn't survive it, but it's a survivable descent rate. So if you ever were just completely hopeless, maybe you lost visual or something, and you didn't think return to home was an option for whatever reason, we're gonna fly with a flight controller. That is something that gives you an option. And here we can see you can pretty comfortably cruise around at a pretty low power setting. You might be able to get even lower. It's a little bit bumpy, so I don't want to go too crazy with it. And like I said, I seem to have this resonance frequency right around mid throttle, which really sets off that vibration. So I'm trying to avoid those exact ranges. And if I give it full throttle, you can see we get up to a pretty decent, this is just an 18650, 3S 18650. You can see we get up to a pretty decent speed there. I'm hitting 120 kilometers one direction. And if going into the wind, hitting 100 and, I'm off here, 105-ish, maybe a little, or 100. So we're hitting somewhere around 110 kilometers per hour with this motor and prop setup. And it is the Brother Hobby motor that I believe Justin recommended. And the prop is a 4x, I want to say 2.5, so it wouldn't be the fastest by 3. That's a tri-blade prop. Wouldn't be the fastest prop by far. In fact, the main reason I'm flying with this one is because I had it on the PETG model, and the PETG model was quite heavy, so I didn't. I wanted to have all the thrust for takeoff that I could. This model being lightweight, back to lightweight PLA or the pre-foamed lightweight PLA. I could probably drop that prop again, and maybe it would help with the jello issues, though. I didn't see them on the PETG model, but again, that might be a shutter speed thing. That reason I wasn't seeing them. It's quite a bit darker right now because of the cloud cover. So either way, we've been flying around for nearly over 11 minutes at this point, and we're still showing 3.7 on the 18650. So still plenty of gas, and obviously we have been taking it very easy here. We've been having fun with it. Yeah, the flight characteristics are fantastic. Roll rate's great. No issue with. We'll go up here at altitude a little bit here. I don't want to crash this thing too early. Here we go. Once you got a little bit of altitude, a little bit of speed. No issues with the loops. Right around, no problem. Ignore that. That's still the original battery settings, not lithium-ion settings. And it'll do the same thing as the Nano Goblin does. If you want to do a loop, you pull really hard, you'll tend to get these. There you go, manual mode. It's not even doing it today. Usually, you kind of get that little pitch bobbing that the Nano Goblin does as well if you do a loop and you pull too hard. Yeah, you're kind of seeing it there. Helps it in manual, get a little more throw out of it. So if you want to do a loop, what you really want to do is keep it smooth all the way around, and then you get a nice loop. Oh, that's going to be an annoying. Oh, there we go. Got to give us a break for a second here. Yeah, I haven't changed that for this model, so it's using normal LiPo settings, not not lithium-ion settings. But you can see normal cruising. I don't think you have any issue getting a solid 20 minutes out of it. Probably longer. I forgot to weigh this airplane, but assuming I don't crash it before the end of the flight here. Ooh, as I say that and get bumped around by the buildings here a bit. I will weigh it and make sure I list the weight so you can kind of get a comparison with whatever version you build. If you see the build portion of this video, you can see I have not optimized it very well. Probably way too much wire. I've purposely left connectors on because what I like about this design is even though it's 3D printed and everyone knows 3D printed airplanes are so vulnerable, they're so fragile and blah blah blah, which is true to a large degree. This airplane is so quick to print and so quick to assemble that I feel like you can build it in such a reasonable time frame that you can have one built and ready to go, and it really only takes you a short time to transition it from parts to airplane if you've got relatively quick way of changing connectors. So that's why I've left it the way I have, rather than for example, everything in my Nano Goblin is direct soldered to cut down on every last ounce of weight. And with this one, I would have chosen not to do that, which does hurt the total weight. You end up a little higher, but even like I said, even with that total weight being higher, performance is still fantastic. Really fun to fly, and like I said, it may not have the same durability or resilience that a Nano Goblin would have or other EPP foam airplane, smaller foam airplane, but the small size of this airplane, just like the Nano Goblin, does give it an edge over similar models. So build it with lightweight PLA, work on keeping it reasonably light, and you won't have, in my mind, you won't have any issue flying it for normal flights, normal operations. Maybe you're not going to use this airplane to go find the tiniest gaps you can, but if you've been watching my flight videos here, the teaser video I did, and I'll probably add some more video during this one showing some of the stuff I did do with it, you're going to see that I did fly this airplane, or one like it, as this is now probably the 4th or 5th one that I've built and flown. You're going to see that I did take this airplane through various gaps, and probably more than I should have, because I ended up crashing quite a few of them. And anyway, that's probably enough for now. That battery critical warning, I don't want to take the goggles off and try and fiddle with that and whatnot. So we'll conclude this flight for now. We'll look into this vibration issue, see something obvious that's causing it. But like I said, we're still 3.4 volts on a Lion, and we've been flying for 16 minutes. This airplane has quite a bit of gas left in it. I don't have the current sensor to exactly show what we've got left, but I wouldn't be surprised if we could probably get another at least 10 minutes out of it. Putting flight time probably around the 25 to 30 minute mark, as long as you're keeping the throttle back, keeping it efficient. So anyway, we'll bring it in for a landing for now, and once I investigate this vibration issue, I might try and take it out again, fix that warning. Oh no. Oh boy. Well, that was not the ideal. Not the ideal. Plane is a little bit more efficient than maybe I took it for when it came to landing. Well, I can't seem to help myself. Guess I wanted to make a new Nano Gremlin, or sorry, a new Gremlin. Anyway, important thing is save the right parts. We want these carbon spars. Don't care so much about the wing. And of course we want to save all the rest of our electronics. And you can see how everything pulled apart. And so that all just kind of goes back together, and once we make the new airframe, and we're back. Anyway guys, you can kind of see the end result there. And I think, or hope, what you can see is just how quick this airplane is going to be going to able to get up and going again. Now obviously this airframe, realistically done. That was a pretty hard hit though. We probably impacted right around here on that roof, and poor plane spun around, tore off the one wing there. But you know, all in all, it really won't be that long to get this thing going again. I'll be 3D printing another one, and as you can see from the build video, it really doesn't take that long to assemble. And because my components are all set up to be modular, this will be a really quick turnaround on here, and even partially because they're modular, they are less likely to get damaged. By the way, here's my new Radio Master Zorro running ELRS. I really like this radio, but if you're looking for a review on it, Bruce over at RC Model Reviews, he's got a good one. It's one of the ones that I watch when deciding whether to get this radio or not, but I've been really happy with it so far. Anyway, we'll put this back together, and we'll probably have another one flying here in a day or so. So, should you 3D print this airplane? Well, if you have a 3D printer and you have some experience building 3D printed airplanes, then I think it's a little bit of a no-brainer. If the Nano Goblin appeals to you, if you've owned one before or would like to get one, you've seen the videos and you think it's an interesting airplane, this is a very reasonable stand-in for that airplane. Now, some of you might be asking, well, 3D printed airplanes are very fragile, they break very easily, what's even the point? And I would have to say that with this design, because of its relatively small size and relatively lightweight, assuming you keep it set up with the pre-foamed or active foaming lightweight PLA, is that it does handle a decent bit of crashing without too much trouble. Yes, if you hit hard enough, you're probably going to break the nose. But the nose is pretty easy to glue on. It can be done right at the field because CA and kicker form essentially an instant bond. And from what I've seen, it will tend to break reasonably cleanly. I have now crashed every single Gremlin that I've built, and at least most of the time I've been wanting to reprint one because there's been some changes to the design, but the majority of them would have been repairable. You could have glued them back together even without having to reprint extra parts. So it does change the 3D printed game a little bit to have an aircraft like this. And in my opinion, not that I'm incredibly experienced with 3D printed airplanes, but I've printed a few now. Using a carbon spar seems to make a real difference. Of the aircraft I've seen, if you crash with a carbon spar, it does seem to help absorb some of the impact, and there's enough flex in the lightweight PLA that minor crashes aren't as likely to create a shattering event like they would with a 3D printed airplane that doesn't have any internal structure or any stronger internal structure like a carbon spar. So overall, I think the design ends up working really well. And as you've seen, the build and print process are very simple and very quick. And so it's not a big deal to have a second airframe sitting ready to go. It's a very little plastic. It's not too much time. You can run it on the printer when you're not doing something else, and you can have another build ready to go. And like I said, if you set your electronics up with being modular in mind, it is very quick to switch over. So yeah, I would say if you have experience, this is without a doubt a worthwhile airplane to try out. If you're new to 3D printing airplanes, there's a little bit of a challenge to it. This airplane is probably easier than most to print, but it doesn't mean you're going to have to spend some time making sure your printer is well tuned. These single wall prints that all 3D printed airplanes will tend to use are a little bit challenging, and you do need to spend some time tuning the print. So you may end up starting with something like the wingtip or the wing and only printing a small section of it to make sure that your printing settings are perfect. But otherwise, I can't say anything negative about this airplane. As far as 3D printed airplanes go, this one is excellent. So anyway, get out there and enjoy, and I'm sure Justin or myself would be very happy to answer any questions. Justin's obviously going to be the subject matter expert, as he designed it, and he's got all the knowledge on the background of the aerodynamics and the rest of it. Anyway, hope you enjoy, and happy flying.